Hi, Math 7A Exam 2, question number 19. We are going to solve this inequality, rational inequality. It's number 19, and the problem is x minus 4 squared over x squared minus 25 is greater than or equal to 0. Greater than or equal to 0, we're only interested in regions, and we have to use the same instructions as the previous page, which means we have to do a sign graph. We're going to shade regions of the sign graph that are positive. So we're going to factor the top and bottom, set the top and the bottom equal to 0, not greater than or less than, but equal to 0. And we're going to solve each of those to get our critical numbers. Put them in the proper order on our number line, and then put this side, the factored left side, over here. Now we're going to choose a test point from each of the 1, 2, 3, 4 regions, plug them in, and see what kind of signs we get for this fraction. Top's always going to be positive no matter what you put in for x because it's squared. So all the tops you see have positive signs. The bottom, we have to judge each of them separately for the two factors, then multiply everything together. We get positive here, negative result here, negative result here, positive result here. We're only shading the regions that are positive. Okay, so that would mean only this region and this region. Let's see what we do with that. We are going to also, step 5, include, because of the equal portion, we're going to include all the endpoints, but only the ones that don't make the bottom 0. Now the bottom will be 0 when x is equal. You can look over here. The bottom will be 0 if x is equal to 5 or negative 5, so those will not be included. That's why we have this region with a round bracket and this region with a round bracket. And then interval notation, negative infinity to negative 5, union together with 5 to infinity. Number 20, use a given 0 to find the remaining zeros of the function. The function for number 20 is f of x equals x cubed minus 2x squared minus 11x plus 52. And the 0 is negative 4. Okay, so this happens to be a third degree polynomial. That means it has 3 complex roots. That would include real and imaginary, and it would also include multiplicity if any root appears more than once. So we know that negative 4 is a root, or 0. That means when we synthetically divide the coefficients of f of x by this negative 4, we absolutely must get a 0 remainder, which indeed we did here. But the reason we're going to go through this synthetic division is because of the other numbers we get when we synthetically divide. So we synthetically divide, and at the bottom we get 1, negative 6, and 13. That means that we can start a factorization of this given polynomial f of x. X minus the 0 that we just found right there. Well, it was actually given to us. We didn't find it. Times the entire polynomial that's down here before the 0. And that's going to be 1 degree lower than third degree that we started with in the top. So it's 1 times x squared minus 6 times x plus 13. Now, since we're down to a quadratic function or quadratic expression here, we can use the quadratic formula to finish the factorization, or to find the rest of the roots, in other words. So we'll use a equals 1, b equals negative 2, c equals 13, plug it into the quadratic formula and simplify. And when we do that, we get 6 plus or minus 4i over 2, but we can factor a 2 out of the top and bottom and cancel it. So our final result is x equals 3 plus or minus 2 times i. What are those? Those are our remaining zeros for this third degree polynomial. They gave us a 0, x equals negative 4, and we knew it was a third degree polynomial, so it had to have 3 more, or at least 1 more with multiplicity 2. Right? So it turns out that we did get 2 more. We got 3 plus or minus, 1 with a plus, 1 with a minus, 2 times I, and we're finished. Now we'll just go ahead and move on to the next problem in this video. We have question number 21. It's an extra credit problem. You must use sign graphs and answer in interval form. Here's a hint, 256 equals 8 times 32. Number 21, the revenue achieved by selling X graphing calculators is figured to be X times 36 minus 0.2x dollars. That's the revenue. The cost of each calculator is $28. Well, if each one costs 28 bucks and you sell X of them, the total cost will be 28 times X. How many graphing calculators must be sold to make a profit? And a profit is defined to be revenue minus cost of at least $51.20. Solution. Profit will equal revenue minus cost. So P of X, the profit, is the revenue, which we discussed as X times 36 minus 0.2x. That was given to us. And then minus the cost. The cost is 28x, so we minus 28x. Get rid of the parentheses and combine like terms. We have the profit equals negative 0.2x squared plus 8x. Now we're going to set this profit greater than or equal to 51.2 because we want to make at least a profit of 51.2. So we have negative 0.2x squared plus 8x is greater than or equal to 51.2. I'm going to get rid of the decimals. I feel uncomfortable working with decimals. You could have kept them. One move to the right on everything will get rid of them. So I'm multiplying everything on each side of the inequality sign by 10. That's the same as moving the decimal one place to the right. That gives us negative 2x squared plus 80x is greater than or equal to 512. Now, this is a quadratic inequality. Move everything to one side on the left and 0 on the right. Factor the non-zero side. We're going to divide both sides by that negative 2 that we factored out. And when we do, because it's a negative 2, it's going to flip the direction of our inequality. We get x squared minus 40x plus 256 is less than or equal to 0. Okay, so we're going to factor the non-zero side and get our critical numbers. They are by setting each of the factors equal to 0. Not greater than or less than, but equal to 0. We end up with x equals positive 32, x equals positive 8. Now we're ready to make our sign graph using our 8 and our 32 to partition the number line. Now remember what we're trying to find. We're trying to find the x values that make this product negative. Okay, so we're looking for negative regions. For each of the factors, we choose a value of x in each of the 3 regions, plug it in, and get a minus times a minus is a plus, minus times a plus is a minus, plus times a plus is a plus. We're only interested in the negative regions, so because of the less than or equal to symbol that we started with. So shade the negative regions, that will be just the middle region. And as far as the endpoint 8 and 32, there was an equal portion in the inequality, so we will be including those with boxy brackets. Oh my goodness, it looks like I didn't use boxy brackets. Why didn't I use boxy brackets? It has to be greater than, I should have used boxy brackets. So let's change our ink to black and let's make these guys boxy brackets. Okay, let's see. Up here. Okay, trying to close that. Got it, got it. You can close. Oh, who cares? Let's scroll down, make this a boxy on the 8, a boxy on the 32. Wait a minute. No! I just realized why I didn't use boxy brackets. Let me erase that. I didn't use boxy brackets because if I had included those endpoints, my profit would have been 0. That makes no sense to have a 0 profit. Okay, so we're using round brackets. Include, no. Exclude, exclude. All right? Because we do not want is the profit. We do not want profit to be equal to 0. All right, that's the reason. Okay, so round bracket on the 8, round bracket on the 32, shade, round brackets on the interval form, and no equal portions on the set notation. And we are finished.